Hi, I'm Jim Ising, Technical Consultant and Marketing Director at Angles Resource, the North American distributor of Fuji products. A few years ago, Fuji introduced a new guide theory called the KR Concept. I'm sure a lot of you are familiar with it by now. It was partly a result of the micro guide craze that started 10 or 12 years ago, and it was partly about how easy it is to cast braided lines. In the end, Fuji engineers and designers introduced a whole new selection of tangle-free K-series guides that took advantage of how limp braid was, and thanks to the popularity of micro guides, how willing consumers were to move to smaller guides. Like the new guide concept before it, KR Concept had the same goal. In fact, the goal of every system or concept Fuji has ever introduced is the same. All of them are about efficiency, which is what I'd like to discuss a little bit today. Now, I realize a lot of this will seem obvious to experienced rod builders, but it never hurts to revisit your ultimate goal with designing a guide train, so hang in there with me for a few minutes. If you're new to rod building and you're always looking for placement charts to position guides, I hope you can begin to change the way you approach the subject of designing a fishing rod. Design is not about the color of the wraps. It's about engineering a system, a whole system of quite a few parts that do what you need them to do as efficiently as possible. So hang with me here. Every cast, regardless of the rod, the blank, the reel, the line, every cast starts with a given amount of energy loaded into the blank that's released with the lure. That energy is the plus side of the equation. On the minus side of the equation, it's simple, it's friction. Friction starts right at the spool. There's friction at the lip of the spool, friction every time the line touches the blank, and friction at every guide ring and frame to the tip of the blank. Finally, there's friction in the air against the lure. If you total up all of the friction in the system and subtract it from that initial energy in the lure we talked about, you've got distance. I don't want to get too far in the weeds here, so let's kind of zoom back out and take a broader look at what this all means for an efficient guide setup. Yeah, we're going to take wind friction and reel friction out of the equation for now. And I should mention we're talking about fishing rods, not distance casting rods. Fishing rods include the additional step of static loading, which pays attention to the way the rod performs under load. Hopefully that load is a fish. So efficiency has two parts: casting efficiency and load efficiency. For now, we will talk about casting efficiency with certain components of friction taken out. Casting efficiency is really nothing more than managing line flow to reduce friction as much as possible. The guides you choose and their position on the blank will determine how the line coming from the spool is managed to the tip. Smooth flowing line is the goal, because it will have fewer touch points along the blank, and obviously that will reduce friction. But the real key is managing the line from the spool to the choke guide, that short section of rod, which is usually called the reduction train. The choke guide is the point on the blank where the line should be running smooth and track with very little friction to the tip of the rod. But here's the important part: how quickly and over what distance this can be accomplished is not only the heart of the KR concept, it is also the key to the overall efficiency of the system. Now, Fuji has done a ton of research on this, and they have shown that you cannot choke all the line coils out too quickly. You can force the line to run smoothly very soon, but not without a lot of added friction against the back of the first ring. If the stripper is too small, it acts like a brake on the whole system, even though it can feel smooth. At the other extreme, a stripper that's too big doesn't manage line enough and just sends the chatter and the chaos of the line to be handled by the next guy. KR Concept addresses all of these issues by using the optimum guide size at the proper height to fit in the guide train where it creates the least amount of friction. Fortunately, Fuji has gone the extra step to define groups of guides that play well with each other. So once you understand the characteristics that help you determine which group is best, you can select the entire reduction train at once as a group. After that, it's about where on the blank you place the guides for the entire group to create the least amount of friction possible. Less friction, less energy lost, more efficiency. Placement, this is important, placement is not subjective. There is a reason for every position. Think for a second about the number of combinations in line, spool size, and reel height. Every different combination can move guide trains up and down the blank in a search for the lowest amount of friction. Fortunately, there are a couple of starting points to help you get started in the right direction. First, a spinning reel points to the choke point on the rod. It seems logical that guides should be in the way of where the line coming from the spool is headed. This way, guides are there to intercept and manage the line where it wants to go, not to change its direction. Now, thanks to the forgiving nature of braided line, there are plenty of folks who don't think the direction a spinning reel faces is very important. I always have the same answer to that. If you have the option, why would you not put the guides in line with where the reel points? And without some defined starting point, an arbitrary stripper guide placement seems to be an invitation for the entire reduction train to get further off track as you build the whole system around one bad position. The second common sense idea is the bullseye position of the entire reduction train, and probably most of you have heard about this. According to Fuji, the final reduction train, when viewed from the stripper to the choke guide, should form concentrically smaller rings down to the choke guide. It seems logical. Why go to all the trouble of getting the stripper in just the right place and then attempt to change the direction of the line flow with a second reduction guide that's higher or lower than the straight path toward the choke guide? If I pull the stripper line up or push it down after it leaves the stripper, doesn't there have to be additional friction there? So how does it come together, and what does it actually look and feel like? Well, the finished rod, I think above all, is quiet. If the line going through the guides is quiet, a lot of other things will fall into place. It's balanced, it's easy to work with for the chosen technique, it's effortless to cast, and it's comfortable. Now, I have a number of rods that check all those boxes, but one in particular I want to share. It's an 8-foot point blank built for long-range pop and cork fishing on Mobile Bay. Here's some drone footage of the performance of this rod.
All right, we're set up out here to do a drone shot of a cast. I'm gonna do a lob cast because that's what I would use if I was fishing a shrimp, a live shrimp, or any kind of pop and cork setup. Got the drone set up to follow me down range. When I get down there, I'll turn around and range with a rangefinder in my pocket, so there won't be any hanky-panky going on here. All right, let's go see how far that went.
You remember earlier in this video when I said that a quiet line flow was a good indicator of a well-designed reduction train. Rewind to the cast with this rod and listen to the line flowing through the guides. The microphone picks up the sound of the drone about 20 feet away, but there's almost no sound of the line coming off the spool. I try to fine-tune all my rods to this point.
I had to swing around this tree here just a little bit, but using a rangefinder so I can come in from any direction I need to. Here's the pop and cork. Here's the rangefinder. See what we got here. That is a 64 and a half yard cast. Let's go back and see if we've got enough battery power to do one more.
Okay, so that rod had three objectives. One was distance, which is critically important drifting shallow water in Mobile Bay for speckled trout. Two was the ability to make the cork pop well downrange, which required the lightweight, length, and crispness of a high modulus blank, like the point blank. And three, it needed to move a lot of line on a hook set to drive hooks home at great distance. It's a very efficient system for doing those three things. So that rod had a defined objective and a design that met those objectives efficiently. Now I realize we haven't talked about placement charts today, or how far out the stripper goes in front of the spool, or anything that will tell you exactly where to take the stripper to the blank. Instead, we've talked about thinking of your objective as you approach a layout and having a fundamental understanding of what you're trying to accomplish along the way. Fuji has supported and promoted this learning method since the first publication of the new guide concept in the late 90s. And they've continued with a complete written explanation of their thinking in the KR concept. A firm understanding of basic information and knowing your goals will allow you to lay out a top performing rod without even picking up a ruler or asking for a placement chart. It's a kind of freedom, really, that can lead you to new ideas and experiments on the next rod you build, regardless of the components you use. I hope you've learned something today, and I hope you enjoyed the video. We'd like to do more of these from Angler's Resource, so if you could leave a comment, subscribe, or offer a suggestion for future videos, we'll do our best to keep the information coming. Until next time, I'm Jim Ising. Let's wrap things up and go fishing.